Welcome. Today we are going to look at a PCR repeated cycling style question. In higher biology or higher human biology, this question is relevant to key area 1.2, part B, replication of DNA. We're going to approach this question here in two parts. Part 1, we're going to identify patterns in the graph, or how long it takes PCR to carry out one full cycling of heating, cooling and heating again to replicate each region of DNA. The second part, part 2, is calculating how many copies of the original DNA molecule count will be present after the given total time. So, let's begin with part 1. First of all, what we're going to do is highlight the context of the question. Okay, so the graph shows how temperatures changes during repeated cycles of a polymerase chain reaction, and then we're going to try and work out if we can see any patterns. So the graph shows repeated patterns of the process. How we're going to distinguish these is we're going to begin at 0 minutes and highlight the first time this point appears again. We're looking for the graph to show a reading of 72 degrees with 1 minute before rising again to 94 degrees. Okay, so what I'm going to do is, if you look from here, where does that point take place again? With 1 minute before it shoots up again, and that point on the graph is exactly here. Right, so this tells us that a cycle takes 4 minutes. Just to confirm that, if you're not sure, go to 8 minutes, which is an additional 4 minutes, and then put across there as well. And you'll find you've got two patterns taking the same amount of time. So each cycle is going to be 4 minutes long. So we've worked out that a cycle takes 4 minutes. Now we can go on to answering the actual question. So I'm just going to quickly highlight the question. Here we go. If there were 500 molecules of DNA at the start, predict how many copies there will be after 20 minutes. Okay, so what I'm going to do is I'm going to double highlight the key information. We've got 500 molecules of DNA at the start, and then we're going to allow the process to take 20 minutes. Right. So, as we know, each cycle takes 4 minutes, and this process is going to be carried out for 20 minutes, there's going to be 5 cycles running. Now, as a rule, the number of copies at the end of the first cycle is going to be double what you start with. So if we know we're starting with 500, at the end of the first cycle, it's going to be double that, which is going to be 1000. Each further cycle will then double the amount of copies. So at the end of the second cycle, 1000 copies will replicate into 2000 copies. But as it's 20 minutes, at 4 minutes a cycle, we're going to need to carry out 5 cycles. Right, so we can write it out like this. I mean, if you're comfortable doing it in your head, please do it. But if you need to write it down, you can. So what I'm going to do is I'm going to do one cycle. Okay, one cycle equals 1000 copies. Okay, because that's double what you begin with. Okay, and as a rule, the first cycle always gives you double what you begin with. The second cycle is going to be double the first cycle, which is going to be 2000. The third cycle is going to be double the second cycle, which gives us 4000. And we keep going like this. Okay, so it doubles every single cycle, which means, of course, in cycle 4, it's going to give 8000 repeated strands of DNA. Now, finally, the fifth cycle, again, 20 minutes divided by 4 gives you 5 cycles. Is going to be double cycle 4, and that is going to give us 16,000 copies of the original DNA molecules, the 500 at the beginning. So going back to the answers to the questions, by following those two stages, we can confidently answer that if there were 500 molecules of DNA at the start, predict how many copies there will be after 20 minutes, knowing that there's 4 minutes in each cycle. The confident answer here is A. 16,000 copies will be there after 20 minutes. Okay, so as usual, please feel free to like, subscribe, share, tell anybody if you think this has been helpful for you. Okay, I'll see you on the next one.